Good afternoon, everybody. My name is Charlie Nicklin. I'm the Chief Executive of IAgrE, and I'd like to thank you all for joining our October presentation. For today's lecture, I'd like to welcome Jonathan Gill, who a number of you will know from his involvement with the Hands Free Hectare project at Harper Adams. Jonathan studied robotics, mechatronics and automation engineering at Plymouth Uni, and for the last 10 years has been involved in researching future farming technology, such as autonomous systems, including drones and robotics. Today, Jonathan is going to share his ideas on visualization techniques and the use of drones. As usual, our lectures, everyone is muted. If you'd like to ask questions, please pop them in the chat function at the bottom, and at the end of the presentation, we'll unmute you so you can ask in person. Okay, over to you, Jonathan.
Excellent. Right, let's go back up. Welcome everybody. It's a pleasure to actually be here for the kind of conversations that we want to have within everything from what we've got from IAgrE. Visualization and drones is the work that I'm actually going to be talking about today, mainly because I had a bit of a change of mind after my conversations with myself on how I was going to display and talk about what I've been doing over the past couple of years. Everybody knows me from what I've done previously, or maybe, and I wanted to go over some of the newer aspects of my particular work. So let's get cracking. Will it click? There we go. So here's me. I'm Jonathan Gill. I'm an agricultural technology specialist. I have a background of robotics, automation, and other different exciting things from my backgrounds from when I started at university, Plymouth University, where I decided to be that little bit of a quirky character, make a robotic shark instead of a little wheeled robot, and then started to get really excited into traveling around the world by doing underwater robotics with ROVs based all the way around the world, and literally getting cited in a number of papers for finding new species and exciting things. I worked at Harper Adams for a number of years, and I'm always known as a keen advocate for drone technology. I've also participated in a Nuffield Farm Scholarship, and that managed to enlighten me and the rest of the people around how to embrace automation in agriculture. So for those who do not know me, and who am I and what have I done? So why do I have the ability to stand or sit in front of everybody here today and talk about what I'm talking about? So I've got a BEng in Robotics and Automated Systems. I have no Masters or PhD. From all my career, I've worked with robotics for 20 plus years. Mechatronics, physically moving things that would allow me to get my actions from thoughts into more precise actions from machines is a great way of allowing me, because I'm a flawed human, to just make things work. I can't fly in the sky and I can't swim underneath the oceans, but the capability for me to make machines to go and do that certainly helps. Therefore, I worked offshore in oceaneering for 7.5 years, mainly in the Northern Hemisphere, but up in amazing places like Greenland to Norway, and then down in the North Sea. I did my Nuffield Farming Scholarship in 2018, and this is where my eyes were really opened to the world of agriculture, because I just had that main understanding of the world and farming based in the United Kingdom. I traveled to 19 different countries, from places far afield as Chile to China and Japan. And these were amazing places to open my eyes up to different methodologies of how we literally grow crops, to the ways how we use technology, even implements, to grow our crops for our families, and the kind of social, economic aspects that has. And that changed my life forever. I must say, after doing that, I never really wanted to just stay in the understanding of farming as it could be and as it was in the UK. I wanted to spread my wings further. I'm known as the co-creator for the Hands Free Hectare and the Hands Free Farm, and that was the autonomous farm system that was run at Harper Adams University. If you haven't seen that, there's some links based in this presentation later on. I've worked as a mechatronics researcher there for another 8 years, and doing other things such as laser weeders and autonomous bale accumulators, and also playing with many, many drones. Finally, my last 2 years, well, nearly 2 years, I've been working for UPL. And that's literally led me into a completely different aspect of working for large corporate companies to then see how I could use technology to bring some really exciting things into not just marketing, but financial savings as well. So this is me starting out in the beginning of my career, sitting in front of machines underneath the ocean virtually, looking at certain things as exciting as a million screens, sonar radar, and other things, including finding World War II mines. This is the ROV that I was used to operating and working subsea. And as you can imagine, these are very hard machines to operate working for. And this was an example of a video where we were down at nearly 7,000 feet. So absolutely epic pressures, really putting the test to mechatronics down to machines working when they needed to in very tough environments. And I've always taken that with me from every different aspect of work, that things need to work when it comes to crunch time. It can't just be that kind of finicky thing, which is just about okay. Hands Free Hectare, I put this in here. So the people who do not know my previous career and the capabilities, I was the co-creator of the Hands Free Hectare with Kit Franklin, another IAgrE member, and also it was really an interesting aspect to understand for myself coming into the farming world, how we could make automation and agriculture start to have a synergy with digital technologies. Precision application, bringing in the aspects from my previous drone work, allowed me to have precise spraying capabilities with the Amazon sprayer that you can see on the left, where we had single nozzle control, allowing us to make sure we didn't do double dosing and we were just spraying where we needed to. And that started to have some really interesting synergies with what my future would have with drone systems. It all comes about how we can make agriculture, technology work together and have this ability to see what we can visualize and bring together. And as you can imagine, every single thing from the Hands Free Hectare needed to be captured somehow. And that was always with me flying a drone, making sure we got the great images and videos that allowed us to then showcase that entire project globally. You could kind of slice me down the center because I'm a massive advocate for drone operations. They don't just have to take images, as we're talking about in this presentation today. They have so many more uses. Drones are starting to become those really exciting additional tools that can not only just deliver your microwave meals directly to your house from Go Eats, but also allowing us to do some really interesting things with agriculture. And I started to play around with that from the very first drone that's shown on the bottom left-hand side there, the Zoom Lion spray robot, which was a fantastic drone, but a very poor spraying machine, to really quirky ideas of me using my larger drones to have a grabber nicknamed the Clam to then fly into our crops and then grab physical things. Drones have a very big impact because they have the capability to not travel on wheels. They can go directly where they want to, faster than they can anywhere else, and they go through the air, which is a nice way of saving time, energy, and efficiencies for certain aspects. Not necessarily everything, but they're a very nifty tool to go and do work with. So what have I been doing the past 2 years? And I thought it was a great way to try and introduce you how my kind of career had changed. I worked at UPL and I was put into a particular area of research and development. And that area was to increase operational efficiencies, agility, and the UPL's core with the R&D Fields program by accelerating the adoption of digital technology solutions. That was my motto to go and work with on a day-to-day basis. Not so much now though, but it means that I've always been working with the capability of making sure we can have efficiencies with monetary amounts using the technologies that I was working with. So as I've just explained, I've been working with drone systems for applications. One of my tasks was to go and train the 9 global research stations on how to go and spray and apply chemicals for those drones in the trials. That was a really important thing, and that allowed the company and myself to get those particular chemicals, to get India and Brazil to have drone application added to the label. Something we were really struggling here within the United Kingdom, but we shall get there hopefully sometime in the future. But the capability of spreading my wings further than just the United Kingdom allowed me to go and do the things that I'd been speculating for a number of years with drone application and drone spraying, and physically get them working, and using the work that I've done, get that on the label. And that's no mean feat. There's an epic amount of work behind that. I also was using drones not just for the application term, but also using them for image processing. As you can imagine, having digital technologies and accelerating efficiencies, having a drone fly over and do certain assessments is a very useful thing. And this needed to be done in a non-black box way. We needed to understand the maths, and we needed to confirm every single step of the way. You can buy these products on the line, such as Drone Deploy, but they're not necessarily a completely open solution, allowing you to understand how the indexes that are being used to assess that particular image is going to come down to the physical number, allowing you to make that physical assessment. And once again, no mean feat, allowing us to then go into the capability of using drone images to then go and do that. Now, unfortunately, I can't show you any of that particular work because that's my previous career, but it does allow me to explain certain aspects of really important things that I've been bringing to development for my work role. And then finally, just it kind of created out of a bit of a quirk and a bit of an interest, but it seemed to really have a very, very interesting use where we were using virtual reality to develop a method to allow trials to be seen globally, reducing the travel expenses and enabling more accessibility for people to go and look at trials, and also allowing year-to-year comparisons, things that you can't do when you are just physically looking at a crop. I was very proud to have those particular things shown in the G20 summit in Nepal, and then also in the House of Commons. So these visualizations have got links later in the presentation, but they've got some really big and interesting uses so far. So how did it all start? Well, the ever-evolving world has meant that we are now sitting in front of a computer having a lunchtime lecture. That means that we are able to use the technologies of the computers and the internet to allow that fast communication, allowing a video and presentation to be shared with you at home. So we're using things such as Zoom, Teams, Slack, all allowing us to run and initiate work-based projects and not necessarily having to be in the same room at the same time. Working from home was very much changed by that world of COVID, making us starting to look after our health, but also did change many a thing for that world afterwards and that new normal where commuting and travel expenses had been changed forever. Things became a lot more expensive with inflation, and the increased numbers of meetings were always one of those hard ones to go and do. And when this technology allowed us to go and virtually do this, well, did it allow you to actually change that methodology? And yes. And the important major aspect is, were you being more efficient, and did you have enough time to just get your job done in that day? So the ever-evolving world led to this idea of VR. Now, what is VR? So I decided to call it the visualization using drones and a tool that we can use on our computer. Virtual reality and the metaverse. So you might have heard the term the metaverse, and is it truly coming? In science fiction, the metaverse is a hypothetical iteration of a unity that we can all immerse ourselves into. So it's just like one big hub we all plug into, and we can all see each other in there. Now, that is being started by large companies like Meta and Apple, but it's not truly there. It's a really interesting thing from being able to take ourselves from a physical location and mentally into a different environment using different key aspects of our senses, such as our eyes and ears, allow us to imagine we're in a completely different environment. And by using these tools that interact with it, allow us to nearly feel like we're in that environment. So virtual reality is where we are physically feeling like we're in a new location. There's a massive interest in this sector. And for those of you who have not understood or seen certain aspects of virtual reality, there was a Steven Spielberg film, Ready Player One, brought out a number of years ago, where this idea of plugging into a world that we could all interact with one another was started to brought to light. As we say, they're not quite there, but there's massive interest in this sector. As you can see, for example, we've got large companies such as Meta to Google, all the way down to Qualcomm and Bourne Studios, all doing some really interesting things with bringing together virtual reality and the physical technology that requires all of the algorithms to allow us to feel like we're in that environment. It's a really, really interesting area, and that's because there are some very interesting uses for it. Google Cardboard is a cheap version of the ability to get into that VR environment, and it allows you to use a mobile phone to get that kind of interaction that you wouldn't usually be able to get to. We all have a mobile phone now, and it was one area that I thought that we were able to bring our mobile phone into an environment and use that expensive technology get us a simulation of what we wanted to go and do. So everything that I'm going to show you later on today is able to actually be worked on with just a Meta headset, which is a very cheap virtual reality headset, just because it was available and able to use, or on a mobile phone using something like the Google Cardboard. Or even something very simple as these little headset units that just clip directly over your mobile phone and use the lenses to give us the correct perception. And they fit in your pocket. Augmented reality is slightly different, and that's where we get the images that are taken in from a camera from a particular smart device, such as a tablet or a mobile phone, and an image is layered over the top of that photograph that's being streamed directly into the machine, allowing us to simulate what that digital image is in that environment. So there's some really good environments of working with Pokemon Go. That created a global phenomenon with people running around cities and countrysides trying to catch particular monsters, all the way to where it might be more useful for some of our other users, where IKEA has brought out their virtual augmented reality simulation, where you can just look at your different types of furniture inside the room to see if it's going to fit or if it's going to have the right environment for you. How does it start linking together with agriculture, however? There's some really good companies starting to bring together, and I've always been a big advocate for working with Drone AG and their technology Skippy Scout. Skippy Scout has started to use their particular drone capability to start capturing images that allow the user to look at their fields and start seeing things in virtual reality. Using that, they can just scroll around using a screen, or they can put on a headset and allow them to visually go to those set locations. The really exciting part of that is it allows you to go to your fields, understand what you're growing, and you can see areas of challenges and reports that we've got from that particular aspect. It's starting to be used in agriculture because the tool allows you to then start seeing things in a different mind's eye that wouldn't normally be able to be brought together. And that's where I'm finding it really exciting to go to. Image capture can be done by really cool things, such as using very small drones. It can be done with 360 cameras, or it can even be done with a mobile phone using a gimbal, allowing you to realize set known positions. However, it does start to become very complicated, and there are artifacts that are created with stitching errors that's starting to come together. So therefore, it is no mean feat to make this start to work easily and correctly. So you can start doing some really cool things really quickly. But as I started to learn the complexities of certain technologies and bringing everything together do start to scale very quickly as soon as you start to create environments and realities that you want to go into. I've just noticed that there's a chat thing that's just coming up. Okay, if you don't mind, I'm just going to bring those questions to everything at the end, if that's okay. And yeah, image capture, the capability can all be done with some really smart technology. Drones, cameras, specialized cameras, and mobile phones all bring these into the environment. And everything starts to come together with using mobile phones and other things too. Okay, now it's going backwards. So this is where my slight apology is, but I have got some certain links to my previous career. As you can see, UPL is nicely branded and logoed from there. On the photograph on the left-hand side, from an environment that was created for a Meta headset, we were able to show off virtual environments and stations, allowing ministers to go and feel like they'd taken the time to go all the way to North Shropshire and go and visit the farm sites, including into the fields. And that was also brought all the way over to the G20 summit over in Nepal, where ministers were also taken from different locations to Spain, India, and all of those 9 other stations that I'd worked with, allowing them to come together. And that's really quite exciting and cool. However, this is my slight apology. I can't show you any of that previous work because it's all covered by them, but it is coming soon. So this is where I have a small glimpse for you guys. It's demo time. This is a great way for me to actually do that. So I'm going to stop sharing and then bring up another screen. Excellent. Okay, so this is one of my mini projects that I was starting to create with Clive Blacker for the Slimer Space project. This is the 360 environment. This can be seen on a mobile phone, it can be seen on a computer screen, and it allows you to have that simulation of going in that 360. We're all relatively familiar with how we use Google Street View, the capability for us to then try and find a postcode or find a pub that we haven't been able to see on a set map. This is very, very similar to this, but taking in images that have been able to actually be captured from drones or specialized cameras to just go and do that set work. Now, this is my apology. I've had to find another piece of technology to kind of throw this together to give a visualization of what we've got going through. So let's go into the 360 environment. And welcome to a certain farm over in Ross and Wye working with the Slimers project. We can have a good look around. We can start seeing some areas that I've started to put set locations on for all our set pots that we are looking at for our slugs. And we can keep on going down in altitude to go and see set areas. Good old Clive Blacker is just being visualized here as he's going taking soil samples. I was able to get off that section for a minute while he allowed me to go and take some drone images. And this is where things start to become really exciting. And this is the severe power of using virtual reality from realized images from capture. Now, these are just snapshots in time. They are not being played in real time at that set location. So it's just like a normal photograph, but a photograph that is taken in full 360. And it allows us to look at the environment that we're working with at our set point. We can see our set slug trap in the environment. And the great thing is, using some of the cool quality cameras that I've got, we can go and see the areas that the cores were being taken at and allowing us to understand the soil type that is being used for the Slimer Space project. This allows us to then really understand what that environment looks like, and I will start bringing together more images over the future at the set locations. We can see that there are more pots placed around in our 10 by 10 set squares, where we've got 100 meters square, a perfect hectare of a set area of traps. This is really nice to then be able to share via a screen to everybody via Zoom. However, this full environment can be realized within a headset or on a mobile phone, just clicking on a certain button. This is shown up on the left-hand side here, on the right-hand side here, if you've actually got that full capability. This is where my apology comes into it. I haven't managed to get it quite working, but I will send out a message to everybody as soon as I've got my server up and running, allowing me to visualize and share everything with everybody. So going back, we just go into the cloud space and allow us to visualize the full reality of what a 360 view can be. That's really nice because we can go into set snapshot areas to actually go over. So thank you, Slimers, to allow me to use that image in the first place. That's some really interesting things. I think we've also got some IAgrE members who are involved with some of that project in the first place. So that's just something I thought I'd just do just because I really needed something to be able to share instead of my previous work. So getting back to my presentation now, let's see where we can go from there. Share screen again. So yeah, the exciting part of all of that is that it allows us to capture images in very cool 360 methodologies. These are native tools that are built into certain drone types. As you can see, I've got a DJI Mini 3 photographed on the side there. It's just one of the drones that I have personally to utilize and have that full capability to go and use. And it's just really nice to make that as a reality thing. There are an awful lot of other operators who are able to actually do all of this in the environment. So market leaders such as Aotel Robots to Youngsea and SkyDuo, including Parrot, DJI and Wingtra, are all really interesting partners that are bringing together drone imagery in set areas, allowing certain realities to then be realized. These are companies to pay attention to because they are doing some really exciting things by using that additional tool of imagery or application to then start bringing together certain things for our environments. And that really starts to play into the capability for us to go and start creating trials or looking at trials and then allowing ourselves to travel virtually across the world and visually go and see certain things such as that slug-based project. None of you have to then travel down to Ross on Wye. Will it allow me to click? Yes, it will. Drones are always coming down in price, and I just wanted to grab a quick image just because it's one of the cheapest drone systems that you can buy on the market that is designed for agriculture. DJI Mavic 3, the multispectral, has got many different lenses designed to allow us to start doing some very interesting things with the imagery. Natively, it allows you to work on multispectral and NDVI analysis, and that will do that in real time. And those sorts of technologies weren't available for anything less than £20,000 a number of years ago. Now everything's starting to come down into price, and the capability for this particular drone to bring together 360 images in full indexes is a really exciting capability that can actually be brought together. So there are some really exciting technologies that are allowing us to do things that we weren't previously able to do. And the nice exciting thing that you can see on the back of that drone is that it's got an RTK antenna, allowing it to have centimeter accuracy to go back to the same location time after time, which is very exciting. The future doesn't involve a pilot, and this is where the capabilities of some of the larger companies are bringing together the reality. DJI have brought together their DJI Dog, which is really for sale now, and that allows a drone to take off and land without a pilot physically having to be in the same location. Legally, there's some little different disclaimers on there, hence the hyperlink at the bottom, allowing us to understand what the UK rules and regulations are, and that means that there's going to be some interesting concepts of training and operation. But having a drone being flown is a thing of the past. Allowing certain projects to be then run in an automated manner, allowing us to go and look at our fields, go and look at our crops at set times, is something that is starting to come into full reality. And that is a really nice thing to be able to then come and see. Back when I started working at Harper Adams in 2012, all those years ago, it was something that I was desperately avid to try and bring to the environment, because we didn't want to have people always looking to the skies and monitoring the drones. With new anti-conflict technologies and understanding airspace, some of these things are starting to be brought into reality. And especially globally, areas of these docks are being brought into certain areas of inspection, looking at power lines to reservoirs, which is a very interesting thing to go and see. It's also interesting to look at the technologies and how they've evolved. And I'm just picking something from the internet just because it's a piece of software that I've previously used and quite like. Pix4D have got the capability to use the images that are captured from drone systems and bring them together using interesting index outputs. We can see non-real colors being brought together on the right-hand side, where we can see certain areas of challenge, which is seen in the red, versus the green, where it's showing there's relatively good vigor within particular areas of crop. And that allows us to make interesting decisions on our environment and what we're doing with our crop, our field, our work area. And that's a really interesting thing to allow us to make set decisions. As you can see at the bottom right-hand side, the exciting area is that we can start producing these prescription maps in a very easy method, allowing ourselves to start saving on application amounts to reducing certain areas of fertilizers, allowing us to save money. These are all really exciting aspects that we can start using drones, the imaging technology, and the entire suite of technology to bring it together, allowing ourselves to realize what differences can be brought together when using them in an entire suite. From this is where I kind of just rattled through to actually go over, but I have also got some other prepared pieces of work on drone application. But it's probably a great time to actually stop and share the time for having questions based on that. So thank you ever so much for taking the time to listen.
Yes, there was a, I'm not sure it's from its TR. I don't know who TR is, but I don't know if you want to unmute and ask your question.
Yes, it's Tim Reynolds.
Tim, how are you doing?
Very well. Basically, obviously, if we look back to agriculture, the introduction of the 3-point linkage was a huge accessibility technology for farmers to actually hang something behind their tractor easily. And obviously, hydraulics enabled farmers with to actually put stuff together to actually transmit power from the tractor to the implement. What I'm seeing with this whole digital space is there's no accessible solutions really, or I'm not familiar with accessible solutions to enable the farmers to actually do the same thing. I mean, obviously BASIC, when it was introduced as a programming language back in the 60s, 70s, enabled users to actually design their own programs, which were very effective. I mean, in 78 as a surveyor, I was designing my own basic software to actually reduce survey levels and doing tax returns and VAT. Even now, there's nothing as accessible, I feel, as a technology savvy person, albeit an old white man, to do the same thing in this digital space. Can you inform your take on this situation?
You're completely right. It's not easy. The technologies that are out there to allow us to visualize things that we are using for our agricultural environment is not developed for us to actually go and use. Everything that we are seeing used by this technology is either developed for gamers, or it's being developed for certain areas that have got more money in it, such as construction. You can see the certain areas of the drone and the imagery application and capture is being utilized for that. However, this is probably one great reason why I decided to step out of the world with working with UPL and then start out as a consultant, is because I'm trying to offer those as a service to people. It's still not an easy thing that comes together, but as a robotic engineer, the exciting areas that I was getting into was not physical automation, but the automation of programs talking to one another and having an image going in, being processed, and then being spat out in an application that could then be utilized. Many different applications. You can start seeing things from Power BI and the Power Apps that are created by Microsoft, and using the vast databases from Azure in that entire architecture. We originally were starting to talk about big data and how the challenges were to then start utilizing those numbers and actually bring information to us. These are things that are tools that are available for us to then break down. I'm familiar with using lots of the different Microsoft tools, allowing us to then break down the big data from all of the information, maybe from your farm, to then get easy visuals to then show you and do certain things. And that's where I'm just starting to know that there's a need. There's certainly not a technology that gives out a easy platform to just make it happen for you, but there's certainly areas to make it happen. And I suppose my area of interest was looking for a large corporate and seeing how we could actually save money. Now it's actually then starting to look at more what is the reality of what we can use these technologies for.
Do you see that application? The one obviously HTML is a good example, and XML interfacing with that. That was an accessible solution for people to actually design their own web pages and really start using the web as a useful tool. Do you see anything in the open source area? I mean, there's open Ag Robots and whatever, which is going to enable this to actually occur in the next 5 years, 10 years. We seem to be getting more complex as opposed to more accessible.
I would disagree with getting more complex. I would say it's been made a lot simpler by using apps from mobile phones and tablets to allow us to control certain things, and the integration of software between one another, allowing us to then physically make those integrations happen. That's where it's becoming more exciting and interesting in this space to enable us in comparison to hold ourselves back. I think when you're referring to the open source environment, there's always open source versions of the particular piece of software. I still use open source CAD systems, allowing me to visualize maps to everything else. But it also then starts allowing you to realize that there are some challenges. Some paid for softwares obviously have got bugs that aren't, are not going to be realized by everyone else. So just using some pieces of software quite useful.
Thank you.
Thanks, Tim.
I was going to ask a question, and it was just when you put up, I was going to type a question in, it was just when you put up the drone hub thing. And I suppose I was thinking about the real-time sort of visualization. And do you foresee more equipment having installed cameras to give you a sort of closer to real-time rather than having to send up drones all the time? Because I suppose if you've got machinery, whether it's an autonomous tractor or a robot or whatever you want to describe it as, going backwards and forwards in a field, if that machine had cameras on it of sufficient quality that was networked into other machines, you've almost got a real-time view of what's going on in the fields without even sending a drone up. That was sort of my thinking, really. That was the first sort of question I've got.
I suppose it all comes down to that networking capability. Before I started writing the presentation that I'm talking about today, I looked back at my Nuffield presentation back from 2019 to look at the challenges. What were my visualizations for the future? And the challenges, and the challenge was, I'd said 5G was a real problem. We weren't able to get the connectivity. We weren't able to get communication to allow certain things to operate and work. Since then, nearly all of us have got a newer mobile phone, and most of them have actually got a 5G antenna with it, allowing us to have faster communication with. Our mobile communications in the UK is pretty poor. It's not as good as other countries such as India, even Brazil. I was out in the center of the fjords in Norway, where I'd got full 5G coverage, allowing me to do video time streaming to my families. This is the capabilities that we need to actually bring into that. But yes, that is starting to come into real time. We've got all drone systems which are able to relay that visual imagery from either its direct communication to now cellular communication, then making that image transfer to us. And then we're only talking about latency times of sub-seconds. And that's a really exciting thing to then have as an environment. But you don't need it all the time. So being able to access the information when it has certain pings up. Just think for the example, like our Ring doorbells that a number of us might have. I know I've got one on my house where I don't need to be looking at anything that's going through. But when something moves in front of my door, like the postman, it'll just start it triggering and do something and then interact with me, allowing me to go through that. And I think that's probably where some of the technologies that from the consumer market will probably find themselves being put onto autonomous systems and work in similar veins.
Okay, and then the second part of my question was really, and I suppose this is sort of almost happening already, is do you sort of see, I suppose the equipment like the drone you put up there for sort of 3,000–4,000 quid is not expensive in terms of what farm equipment costs, but is it going to be more likely that it's going to be service providers use this equipment almost like contractors to farmers, rather than having farmers having to get much more savvy with this type of equipment? I suppose you see it with, you know, harvesting machines. Once upon a time, everybody had their own combine. These days, there's quite a lot of farms now use contractors to do that. Is it going to be the same with this sort of technology, where you're better off leaving it to a specialist to come in and provide you with a service, you know, with a professional drone, you know, rather than the farm trying to do it themselves?
There's certainly aspects of the cost being indicative to stopping people getting and buying that technology, and certainly the challenge of buying a new drone, it's nearly out of date as soon as you've got it, and then that being a worry to then keep its operational capability for the future. But if you start looking at companies who are using drones for their capabilities, and we're talking about larger areas of areas for inspection, Drone AG with their Skippy Scout can nearly guarantee that the costs of using that system for oilseed rape will allow them to save the money that is cost from the drone system by reducing fertilizer over the first year. And then that allows you to then start saving for the future, which is a really exciting thing for that as a potential. I'm coming from an area where crop trials were incredibly expensive to run for a 30 by 50 area plot with maybe 50 separate plots in there, and it cost anywhere between 15 to 20,000 pounds per trial. The inspections of that are very much worth you doing from digital technologies, because it's able to give you a better understanding of that number in comparison to your humanistic understanding of what a green index is versus the amount of chlorosis that has actually happened to that particular plant, and insect damage across all the different categories. There's loads of different aspects to go into it. I'm not saying it's cheap, and I'm not saying it's easy for everybody, but there are certain aspects where it's probably going to start coming more useful. And then once again, people start buying these drones, which I've got one literally here, my little DJI Mini, which is, I think you can buy for about £500 now. And that allows you to get some very interesting points of view. Not saying it's completely integrated with some of the technologies which are available now, but it certainly allows you to get an eye in the sky and be very helpful.
Okay, thanks. Tim Jamin, question?
Yeah, Jonathan, I just wondered, as is the case with so many really good technologies, it gets devalued by people, you know, working their ways into them and making life really awkward. Do you have any concerns about this happening with drones, that people will be able to take them over and just mess up what you're doing?
I think that these concerns are being actively pursued by the companies who are releasing technology such as drone in the box, the capability for it to then be overtaken and looked after. But there are some incredibly good encryption capabilities for computers, and that's being brought into all of that. And I was at a demonstration a couple of weeks ago with HeliGuy talking about the security concerns that they have that, and there's some very good set up behind the back of it to prevent these things being taken over and being used for bad terms in comparison to for good. I think that the bigger area that I've got more concern about the drone being taken over is more like the data that's being captured and how you're storing that information to then be used for something else. That's another aspect that we probably don't tend to think about. The drone's probably quite secure in itself doing the flight and the operation, but the data after you've actually downloaded it and done some other things has always got some interesting concerns. And that's why America asked DJI, or forced DJI, to then make sure that all the information wasn't being sent back to their Chinese servers.
Okay, thanks very much. Thank you.
Okay, Alistair Phillips, question.
Hang on, hopefully that will come up. Yeah, hello. Yeah, I was really following up David's thing here. You know, you've got some good images from the drones and showing hydrological or insect damage or lack or excess of fertilizer. What are the tools for translating these into actually either command structures for the sprayers and so on in the fields, or detailed outputs? You know, at the moment you seem to end up with this eye vision view of things going on in the fields. Where does that plug in? What's the next bit that then feeds that into practical hands-on or machine-on controls systems?
Okay, so that's a good question. It's not easy at the moment. Let's say it's not a direct plug-in for all machines to make it happen. The tool that I chose, Pix4D Fields, was one because it does allow a full process from imagery to be captured, to then be processed and then output separate zonal controls to a good number of machinery. So it'll produce a shapefile that can be interpreted by many different types of sprayer manufacturer. It's not perfect, and it is able to do some things that aren't able to be available in other aspects. If you look at a completely different technology, and as I say, the reasons why I've put up Skippy Scout was using their scouting mechanism of going to separate points and then doing separate analysis on very close separate areas. That brings together their fertilization plan, and that allows them to output separate files for you directly. And that is just one simple tool of making that happen for you. Once again, it's not an easy process behind the back of it. There's lots of gears whirling like the back of a clock, but the simple process is using something like that. But you do pay for a service to enable that to happen. Does that
I suppose I was just wondering whether, I mean, when we've got CAN bus coming in for control of tractors and implements, and all the major manufacturers were doing their own semi-implementations of it, so things weren't completely compatible, and they're still not completely compatible. Whether we need some overview, maybe by the institution, of standards so that things become easily compatible, rather than lots of bespoke bits of this and that, and you hope at the end of the day it's going to work properly.
I do believe there is a standard being brought together for sprayer information to allow it to then be compatible. But once again, it's not necessarily being run by all the larger players in the market to actually then come together. I think Amazon were one of the major players to allow it to be more easy, but it's still, once again, not an easy solution to then come together. Once again, it comes down to money and time to then make things happen.
Anybody got any more questions?
I gather Python, a lot of these new applications are written in Python. Is that something that we can actually see is worth spending time developing skills in?
My background is using lots of software tools. QGIS, which is an interesting program, allows us to do lots of things with mapping, allows you to plug in certain pieces of software and write code to do certain things, allowing Python code. Also just operating a Raspberry Pi to then go and do physical actions using its software and other things. I built one the other week and I programmed it in Node-RED and then added certain aspects to allow me to upload an SD card directly to a, what was it, to an Azure database, allowing me to just literally make my life easy with a touchscreen. Press one button and it uploads it directly where it needs to go with anything else. So those sorts of pieces of technology are very useful to then go and do. However, I would just say, unless you've got a project that you really need to do, you won't necessarily have the passion to then make it happen unless it's something that needs to be solved. So I got the challenge that I needed to upload drone imagery directly to a database. Once again, that was my passion to get that solved and figured for you. Unless you've got that particular challenge, I would say it might just be something that you're not getting the full out of. But that's my opinion. Everybody's allowed that, but crack on. I would love you to actually do something with it.
Okay. Any more questions?
Yeah, just one. Sorry, from Tim Shannon. This is, do you have any concerns about the amount of data all these things are going to be producing? Because I don't know if it's correct, but I read recently that the energy required to store data has now exceeded all the energy used by airlines, which is a bit frightening. So is that, I mean, how far can we go? You think of all the data that's held by YouTube. It's just mind-boggling. And can we go on doing that?
You're right. Data is not static anymore. It used to be in a hard drive. It used to be in a floppy disk. It used to be, as soon as you stopped using it, it didn't take any energy to then maintain. Now, nearly all of us probably don't have static memory on our computer anymore. We're literally just sending it directly to some kind of online update from our mobile phones, from our iCloud, all the way to our Microsoft OneDrive to then go and do. And it does involve energy to actually run and go and do that. It needs to be done responsibly and safely as the set point. It is taking a lot of energy, but if you do read some of the articles from Google recently having their new solar-based and powered services, including their geothermal powered based databases, is a really interesting thing to go and do. However, these are probably just marketing PR more than the full capability to deal with all our data in the first place. But my personal challenge out of all of that is how can I actually use and work with my data in the first place? So the tools that were mining big data and looking at large databases were really hard about 10 years ago. Now I've got interactive tools that I can use from systems such as Microsoft to then make that happen.
Do I understand from what you're saying that the energy is actually only used during the transfer of data, or is energy used to store those data indefinitely? What's the energy required to actually store those data?
It's constant flux to then go over. It does take more energy to actually then store it, but the drive systems and the databases that are actually holding it aren't on tapes anymore. They're literally allowing us to have instant access to it, which will take energy to maintain it and be on.
Okay, thank you.
Interesting point, that really, isn't it? Yeah.
Richard,
Okay,
Richard,
sorry.
can I ask a question?
Yes.
Yeah. Just on what everybody else has just said, and everything else, my scenario is what happens when that big volcano goes off and we lose everything?
I'm really
Well, I
sorry,
mean,
Richard, but that's
it's
probably
happened in
not
the last
within drones
25
of
years.
visualization.
But yes, but you lost all your data and you lost all your records.
I would say, in all honesty, everything for database is kept in a very secure way. It's done in a RAID methodology, so we can keep data infinitely without it having to have energy. It's just our accessibility to have it instantly when you need to watch your YouTube video of a cat licking a screen, needs to then be available. These are really interesting points, but the data usage for keeping our latencies incredibly low does use power and energy to make that happen. It can be done in an easier method by edge computing, by having localized stores to then not transfer all around the world, but it then doesn't become as efficient to actually make that happen. However, let's just go over the major point of all of this one. When the volcano does go off and our access to all our data, we've probably got bigger problems than just trying to access some of our numbers.
This is my point. The new technology is taking away the basic skills for coping with things without all this technology.
Oh, completely. Yeah, no, I've stopped actually using an index on a encyclopedia from now on. I just use Google. I think that's the same for nearly all of us. Yeah. A lot of the skills for actually going over. However, I am a Gen X and I can actually look through a book and actually go through all of those things. We still need to maintain our knowledge and capabilities of doing things with technology and kind of instead of just relying on it. And I'm still a massive advocate out of all of this is that there's human in the loop. It's not just being run by AI making decisions of where we're putting crop protection products and not into it.
Okay, well,
I must admit, this is the same problem when ICT was taught in schools, and it turned out that actually all they were teaching was the use of Microsoft Office products, which really is not IT. And I know Raspberry Pi is trying to actually sort of make things open up a little bit more. But I see we're moving more down that line of ICT in schools, where it's just linked to a software application, than actually going back to the raw understanding and being able to put useful things together using the technology.
Yeah, that's a bigger question. Alistair, you'd got a question.
Well, it was really a comment. It's outside this and we're out of time really, but from Richard and to a certain extent David, but from Richard's thing, it is a great worry. It's not so much the volcano going off, it's actually war. All the nuclear powers, including ourselves, have got NEMP weapons, which is high-level nuclear explosions, which will take out all satellite and all mobile phones networks instantly. 2 over the UK would take out the whole of the UK. We've all got them. And we're relying increasingly on this cloud stuff, which is using vast amounts of power. I was living down near Ely. I live in Scotland now, but there was a data centre proposed in Sutton in Ely, in Cambridgeshire, and this data centre was going to use 50 megawatts of power continuously, and it was actually turned down because it might have had an effect on the microclimate around the area. This big plume of heat, there was nowhere to use the heat. It was going straight up to the atmosphere using the 50 megawatts. So these are issues that actually are worth considering, but it's outside the realm of this meeting. Thank you.
Okay, I better draw things to a close because we are just over an hour. So thank you, Jonathan, for the excellent presentation. It's very much appreciated. I'm sure everybody found it extremely interesting and thought-provoking, especially the last part of the discussion. So I'd like to thank everybody for joining us today and hope you'll join us for our next lecture on the 14th of November, where we'll be joined by IAgrE Honorary Fellow and ex-President Richard Robinson, who's going to talk about his life in the industry and what he got up to in the early days. I'd also like to remind you that booking is open for our annual conference on the 1st of November. The conference this year is online and we're looking at the efficiency and sustainability of food production. The event is on our website, so please get yourself registered. So all that's left to say is thanks again, and we'll see you next time. Bye-bye.